Question is the force in the member PQ. We have to find out the force in this member PQ. The truss is given as PQR and the force F is acting at Q. From the figure we know that. So if we conventionally negative sign indicates compression, positive indicates tension. So first we will find out the force in beam QR. Force in QR is equal to F root 2. So force in PQ is equal to minus FQR by into cos 45, that is equal to minus F root 2 by 1 by root 2, that is equal to minus F. Negative sign indicates compression, so F compression is the answer. F compression, option A is correct. The question, a glucose solution, we are generally represented the glucose solution by C6H12O6 of morality 1.5 into 10 to the power minus 3 is completely oxidized to CO2 and H2O by this reaction. What is the amount of oxygen required to oxidize 1 liter of glucose? We have to calculate the amount of oxygen that is required to oxidize to get this CO2 and H2O. So we know the molecular weight of glucose is equal to 6 into carbon is 12 plus 12 into hydrogen is 1 plus 6 into oxygen is 16, that is equal to 180 grams. So the morality is given as weight of C6H12O6 in grams divided by molecular weight of glucose into 100,000, that is equal to 1.5 into 10 to the power of minus 3 is equal to W1 by molecular weight is 180 grams into 1000, that implies W1 is equal to 2.7 into 10 to the power of minus 4 grams. Now 1 mole of glucose requires 6 moles of oxygen, that we know from this equation. Therefore 180 grams of glucose requires 6 into 180, that is equal to 1, sorry, not 180, 16 2s are 32 grams of oxygen. So 16 to 192, 632s are 192 grams of O2 is required. So 1 gram of glucose requires 192 by 180 grams of oxygen. So 2.7 into 10 to the power of minus 4 grams of glucose requires 192 by 180 into 2.7 into 10 to the power of minus 4 grams, that is equal to 2.88 into 10 to the power of minus 4 grams. 2.88 into 10 to the power of minus 4. So sorry, all the options are in terms of 10 to the power of minus 4. So option B is correct. Question is for 5-day BOD of a wastewater sample is obtained as 5-day BOD is equal to L at 5 days, we can take it as 150 milligrams per liter, and K is given as 0.01 per hour. So KD is equal to 0.434 K, that is equal to 0.434. K is 0.01 per hour. We have to find out ultimate BOD, LU, that is equal to L5 is equal to LU into 1 minus 10 to the power minus KD into T. T is in days. So LU, we have to find out L5, we know L5 is 150 milligrams per liter, 1 minus 10 to the power minus KD is 0.434 into 0.01 into 5 days, that in terms of hours is 24 hours per day. So we are going to get LU is equal to 214.72 milligrams per liter, that is approximately is equal to 250 milligrams per liter. So option D is correct. The question is, a shaft was initially subjected to bending moment and then subjected to torsion. Bending moment and torque. If the magnitude of bending moment is found to be this same as that of torque, M is equal to T is given. Then the ratio of maximum bending stress to that of shear stress. We have to find out the bending stress to the shear stress ratio. This we have to find out. We know the relationship M by I, moment of inertia, is equal to bending stress by Y, torque by J, polar moment of inertia, into tau by R. So by using this relationship I and J is I by d by 2. So we can calculate the, so these two things are going to cancel. So we can get the bending stress to shear stress is equal to 2. So option C is correct. The question is, a spherical vessel with an inside diameter of 2 meters. Inside diameter D is given as 2 meters. Is made of a material having an allowable stress in tension. Stress allowable sigma is given as 4000 kg per centimeter square. The thickness of the shell to withstand a pressure is given as 20 kg per centimeter square. We have to find out the thickness up to which it is able to resist this much of pressure. So we know for the hoop stress is equal to PD by 4T. Stress is given as 400, that P is given as 20, D is given as 2 meters, that is 2 into 10, 4T. T is equal to 2.5 centimeters. So option C is correct.